Welcome to another day on the Journey Shake Chem. Please do the 2 warm-up questions to the best of your ability, and we'll go over them in a moment. The question in number 1 asks for us to determine the oxidation number of the underlined element. In A, we have a whole compound, but it's easier to do the oxidation number when you take it out of the compound and look at the polyatomic ion by itself. Sulfate is a polyatomic ion with a -2 charge. So I'm going to set the whole thing equal to -2 instead of 0 as a compound would be. Oxygen is -2 times 4 is -8. Sulfur is my unknown. When I do the math, I find that sulfur is +6. Now in B, I have a compound and there is no polyatomic ion. So I'm going to set it equal to 0. Oxygen is -2. Times 3 is -6. There are 2 nitrogens. So minus 2x minus 6 equals 0. And therefore, nitrogen is +3. Again, we have a compound. These are nonmetals with nonmetals. So if we were naming it, we could use either the prefixes or the Roman numerals. But I still would have to find the charge of this phosphorus if I was using the Roman numerals. So oxygen is -2. There are 5 of them. That gives me a -10. Compounds are equal to 0. And there are 2 phosphorus. Therefore, phosphorus is +5 in this case. In D, sulfide is telling me that sulfur is in the negative position. It's a binary compound with a -2 charge here. Compounds are 0, and therefore lead is +2. In this case, we're looking for the phosphorus. So again, I will take the phosphate out of the compound. And look, phosphate is always PO4, just like a car always has 4 tires. PO4 always has 4 oxygens. And its overall charge is -3. That never changes. So oxygen is -2. There are 4 of them. That gives me a -8. The whole polyatomic ion has an overall charge of -3. Therefore, phosphate is the phosphorus is +5. Again, I'm going to pull this polyatomic ion out of the compound, and it has a -1 charge. Now, I could tell it's -1 if I didn't know, because strontium is always +2, and we're going to talk about that in a moment. So oxygen is -2. There are 2 of them, which gives me a -4. The whole polyatomic ion has an overall charge of -1, and therefore nitrogen is +3. So that's how we do that problem. Before I begin number 2, I would like to remind you of some very important facts. If you get out your basic periodic chart that we've had from the beginning, and I would like for you to outline some parts on that periodic chart. That would be the first 2 columns. I would like you to make them bold and dark and highlight maybe. Because everything in the first column, the alkali metals are always +1. The alkaline earth metals are always +2. And then we have the silly 6. They would be aluminum is always +3. Silver is always +1. Cadmium is always +2. Zinc is always +2. And then we have bismuth, gallium that are also +3. Those are the silly 6. So you need to put on the periodic chart that you're always using, mark these areas, because these never change. And if they never change, I don't need a Roman numeral. I just need to understand what their charge is. So that brings me to number 2. The first thing I do when I see these words is I write the charges above the word. Zinc is always +2. Chlorine is -1. The common multiple between 2 and 1 is 2. So it is ZnCl2, because if I multiply the chlorine by 2, I get +2, and -2 is 0, and compounds must be 0. In B, the Roman numeral is telling me that copper is +1, because copper is not one of the ones that's always the same. So I have to show a Roman numeral to see what its charge is. So copper is +1. The Roman numeral is always the positive charge on the first element. Oxygen follows its periodic position. It is -2. Therefore, I must multiply the copper by 2, because the common multiple between 1 and 2 is 2. So Cu subscript 2O. This small number is called a subscript. This Roman numeral 6 is saying that sulfur is +6. Oxygen is -2. The least common multiple between 6 and 2 is 6. So it's SO3. In the case of D, the first thing I look at is tin. Is tin one of the ones that never changes? No, it changes. So I have to find its charge. Well, dichromate has a -2 charge. And there are 2 of them. That gives me a -4, and compounds must be 0. Therefore, tin is +4. Tin, Roman numeral 4, dichromate. Dichromate is a polyatomic ion, one of the ones that you're going to have to know. And the sooner you learn them, the better off you're going to be, because the day of the quiz comes really quickly. I would suggest you learn a couple, 2 or 3 a day, so that you'll be ready. Again, iron is not one of the ones that is always the same, so we must have a Roman numeral. Acetate is -1. There are 2 of them. That gives me a -2 on the acetate. Compounds are 0. Therefore, iron must be +2. Iron, Roman numeral 2, acetate. Now, cadmium is one of the silly 6, so I don't need a Roman numeral. So it's just cadmium cyanide. Cadmium cyanide. Now, I understand that you may be having some problems in doing these different naming of compounds. However, you need to take out the rules for naming compounds, the very first naming compounds worksheets, because all of that gives us information that we may be able to use. And you really need to focus on those polyatomic ions. Just keep trying. I know you can do it. You're just hang in there and you'll be fine. Now, there is one thing that you have to learn today that's brand new. And I'll come back to that in a moment. Now we have some very important molecules for you to be aware of. They have a special name. They're called diatomic molecules. Diatomic molecules. These are molecules that when they're by themselves, they always hook up with another one, just like themselves. They like to be in pairs. Now, they are iodine, bromine, chlorine, fluorine, oxygen, nitrogen, and hydrogen. Now, the important thing about these is when they're by themselves, they always combine with one. Now, I have a little simple sentence for you to remember which ones they are. I bring, or brought if you prefer, clay for our new house. So it's very important to understand that when these guys are by themselves, they always want to be together. And if we notice that bromine has 7 dots, 7 valence electrons, And this bromine has 7 valence electrons. I can see that they're sharing electrons, and that gives both of them an octet, which is what is necessary for stability. And molecules always want to get to 0, so this is how they do that. Hydrogen has only 1 dot, and so it gets a duet when it's combined with another hydrogen. So we've heard a lot about oxygen. We know that we breathe oxygen, and that's why it's diatomic, because it's O2. 2 of them always combine together. And how they do that specifically, we'll talk about later on. So that's all I needed to give you today. I hope you enjoy those diatomic molecules. Don't forget the line, I brought clay for our new house, and that's how you can remember them. So that was fun, and thank you, and I can't wait to see you tomorrow.